Welcome back to Pre-Calculus. This is a quick introduction to the beginning parts of section 6.3, and let's just dive right into it. First, consider the unit circle again. We want to look at the sine of 30. A sine of 30 degrees, we know all about SOHCAHTOA. It's going to be opposite or hypotenuse. It's going to be 1/2 over 1 or 1/2. Now let's also look at 30 plus half a circle plus another 180 for a total of 210. So the sine of 210 is what? Well, this time the opposite is negative 1/2, hypotenuse is 1, so the sine of 210 is negative 1/2. Consider the sine of 390. Where in the world is 390? Well, let's go all the way around 360 and another 30 degrees, so this is also 390. It obviously comes right back around again to the sine being 1/2 over 1, so we have a repeat here. Now that's to give you a quick idea of the cyclical nature of sine. It's called a periodic function. By periodic we mean as we go around the circle time and time again, it's going to start repeating itself every 360 degrees. So the sine of 30 is 1/2. The sine of 390 is 1/2. Add another 360, what's that going to be? The sine of 750 will be 1/2. It repeats itself every 360 degrees. That is the period of sine, 360 degrees. Better known to us as a period of 2 pi. So that means we have our first property here, which is expressed on the bottom of page 375, the fact that the sine of theta plus 2 pi times anything, times any integer, will still be the same as the sine of theta. In other words, the sine of 30 plus another 180 times k, or 180, will be the same, 360. 360 times any number k will be the same as the sine of 30. Or the sine of 30 plus 720 will be the same as the sine of 30. Or the sine of 30 plus, that's not supposed to equal sign, plus 30 plus 6 pi. 6 pi radians, these are degrees. If I'm going to use radians here, I guess I should use radians here. What is 30 degrees in radians? Good, pi over 6. So pi over 6 plus 6 pi will be the same as the sine of pi over 6. Simply saying that the values of sine repeat themselves every 2 pi radians, or every 360 degrees. Likewise, cosine does the same thing. I'm not going to go through any examples of that, but cosine does the same thing. Looking at this, I realize that could potentially flood your brains a little bit. What is k? K is any integer, so it says if I take theta and add 1 2 pi to it, I'll get the same thing as sine of theta. If I take theta and add 1 times 2 pi to it, well, 2 times 2 pi, or 4 pi to it, I'll simply get the same thing back. If I multiply by 3, 6 pi, as in this example, I still get the same thing as I would have with just theta alone. And again, same thing for cosine. Now, looking over page 376, there's the one function that's different than that is tangent. Tangent, and just to save some time here, some time and mental energy, tangent repeats itself not every 2 pi or every 360 degrees, but tangent actually repeats itself every 1 pi or every 180 degrees. As we go around the circle, every time you go halfway around the circle, you'll find the tangent value will repeat itself. Meaning that, for instance, the tangent of, how about the tangent of 30 degrees will be the same thing as the tangent of 30 plus 180, or the tangent of 210 degrees. These will be equal. So tangent repeats itself every 1 pi, or every 180 degrees, making tangent also a periodic function. That is expressed as simply tangent of theta plus pi times some integer, whatever integer you want, times k, will be equal to simply the tangent of theta. And make sure I didn't, actually I don't even see that one in the book here. That's interesting. They did that for sine and cosine, but I don't see it spelled out that clearly for tangent. But, oh, I see how they did it. Okay. Yeah, all right. Same concept though. All right, let's move on. That also applies, of course, to the reciprocals of all those. Same rules for the reciprocals. Now, how do we apply that? Let's find the sine of 17 pi over 4 without a calculator. No problem. We know the sine repeats itself every 2 pi. Let's change 17 pi over 4 to this. Let's change it to sine of, what is 17 fourths? Well, remember your basic arithmetic. How many 4s go into 17? 4 with 1 left over, that's 4 and 1/4 pi. Of that 4 and 1/4 pi, we can throw out 4 pi of it. Because 4 pi, think of it this way, isn't this the same thing as 4 pi plus another 1/4 pi? 4 and a 4th pi, 4 pi, plus a 4th pi. Well, if this thing repeats itself every 2 pi, I can toss out any multiples of 2 pi. So I can toss out that 4 pi. This thing is simply going to be equal to the sine of 1/4 pi, well, better known as pi over 4. And doing the sine of pi over 4, you take your unit circle. Pi over 4 is halfway between 0 and pi over 2. So pi over 4 is here. That's a 45-45 triangle. We know the rules here. If that's 1, this side is going to be square root of 2 over 2. So is this one, square root of 2 over 2. So the sine is opposite of hypotenuse. So it's going to be square root of 2 over 2. That's old stuff. So the point is, given something like this, you can figure out how many multiples of 2 pi are in that and just toss them out. And what are you left with? We're left with 1/4 pi. Next example they have is cosine of 5 pi. Cosine of 5 pi. Well, that was pretty easy because 5 pi is not that the same thing as cosine of 4 pi plus 1 pi, a total of 5 pi. Well, 4 pi we can toss out. So this is equal to the cosine of just 1 pi. And we look at the unit circle again, and we find out where is pi. It's over here. Do your little imaginary circle with the 0 height there. And cosine being so katoa, a over h, adjacent over hypotenuse. Watch out because the adjacent is -1, the hypotenuse is +1. So the cosine of pi, of 5 pi, and pi will be -1. So we simply toss out any multiples of 2 pi. We tossed out 2 pi's. Or we tossed out 4 pi, we're left with 1 pi. We find the cosine of 1 pi, we've got it, we're done. The next example is tangent. Watch out, don't forget. Tangent is a little different. Tangent of 5 pi over 4. Okay, tangent repeats itself every 1 pi. So we toss out any multiples of 1 pi. So how many 1 pi's are in this? Well, what is 5 pi over 4? It's the tangent of 1 and 1/4 pi, better known as the tangent of 1/4, try that again, 1 pi plus a 4th pi, 1 and a 4th pi, 1 pi and a 4th pi. With tangent, we toss out any multiples of 1 pi. Well, there's a multiple of 1 pi, toss it out. So we extract 1 pi or 2 pi or 3 pi or 4 pi out of this and see what we're left with. If I take 1 pi out of this, I'm left with 1/4 pi. So I'm finding the tangent of 1/4 pi. And the tangent of 1/4 pi, 1/4 pi being here. And if that's 1, that's square root of 2 over 2. That's square root of 2 over 2. And tangent being opposite over adjacent, that'll be equal to 1. So this guy, our original problem, was equal to 1. All right, so once again, for sine and cosine, you toss out any multiples of 2 pi, or any multiples of 360 degrees. For tangent, you toss out any multiples of 1 pi, or any multiples of 180 degrees, because they are periodic functions. There are examples, well, the 3 examples I just looked at are here on page 376. From there, we move on to the next concept they throw at us. And they spend an entire, well, 2/3 of a page here simply explaining this that we have already been through. I believe we presented this in class the last time we met in person, and that is, in the first quadrant, everything is positive, sine, cosine, tangent, and their reciprocals. In the second quadrant, all students, sine is positive, and sine's reciprocal, which is what? Yeah, cosecant. Those are positive, everything else is negative. All students take, in this one, tangent is positive, and tangent's reciprocal, which is, yeah, cotangent. Those two are positive, everything else is negative. And here, all students take chemistry, cosine is positive, and cosine's reciprocal, which is, you got it, secant. So cosine and secant are positive, everything else is negative. That can be very helpful. You can live without that, but it can be very helpful. Now, I only want to throw one more new concept at you, and the assignment I'm going to give you is quite straightforward and short. Consider this question. In light of all students take chemistry, can we figure out the quadrant that this angle is in? Angle theta. What if I happen to know that the sine of theta is less than 0? In ordinary human language, what's that mean? That the sine of theta is negative. And we know that the cosine of theta is also negative. That's given information. We're told, hey, I've got a particular angle, theta, don't know what the angle is, but I do happen to have some inside knowledge. Somebody told me that its sine is negative, and its cosine is also negative. Well, go to your unit circle, apply all students take chemistry. The fact that this guy's sine is negative means it can't be here because here everything's positive. It can't be here because here sine is positive. Our sine is negative. So that means if the sine is going to be negative, it's got to be either here or here. Because sine is positive here and here, sine is negative every place else. So this particular theta, if its sine is negative, it's got to be here or here. But we also know that for the same angle, the cosine is also negative. Well, where is cosine negative? Well, they're all positive here, so that's no good. Only sine is positive here. So it could be here. Cosine is negative here. But Cosine is also negative here. However, here, cosine is positive. So looking at this information, you ask yourself, where is the only quadrant where both the sine and the cosine are going to be negative? This is it. Third quadrant wins. This guy is in the third quadrant. That's all there is to it. You take the information of these two inequalities and decide which quadrant must it be in. Again, we're looking for that one quadrant where the sine is negative and the cosine is negative, using all students take chemistry. Let's see what else we have here for any examples they throw at us. Actually, they figured this is easy enough. They only gave us one example. Identities. They also throw in this section, I might as well mention it, but this will not be on the new assignment, but since this is old stuff, I'll go ahead and throw this out there. We know that cosecant of theta is the reciprocal of, think about your sine, cosine, tangent, cotangent, secant, cosecant, reciprocals, reciprocals, reciprocals. One of the few things I remember that they taught me in high school. Well, cosecant is the reciprocal of sine. So is it not therefore true that cosecant of theta must be 1 over the sine of theta? Yeah. That's one of our reciprocal identities. The other reciprocal identities, secant of theta will be equal to 1 over, secant is 1 over cosine theta. And lastly, cosecant of theta is going to be, no, we did that one, sorry. Cotangent of theta is going to be equal to the reciprocal of tangent, or 1 over tangent theta. We could just as well write these the other way around. I could have said sine of theta equals 1 over cosecant, or cosine equals 1 over secant, or tangent equals 1 over cotangent, same thing. So those are the your first official trigonometric identities listed at the top of page 378. But then furthermore, remember that when you have an ordered pair, sine of your theta is going to be the y value, I don't write like that, is equal to the y value. Cosine of your theta is going to be the x value. Remember, it's in a counterintuitive direction. And tangent of theta is just this guy over that guy, or y over x. Well, one moment here. Doesn't that therefore mean that the tangent of theta is y over x, but y is sine over x, which is cosine. And that is what the book is referring to as your quotient identity. The tangent equals sine over cosine. That's important. That's going to come in very, very handy later on. But likewise, what's the reciprocal of tangent? Reciprocal of tangent is cotangent. So the cotangent of theta must be the reciprocal of this, which is cosine of theta over sine of theta. So now you have your first 5 official identities, your trigonometric identities, that are going to be quite important to you in the future. And believe it or not, we're stopping right there. We're going to go on with example 3 in the next video. In the meantime, based on just this and nothing more, is your assignment, which shall be page 384, numbers 12 through 34 even. 34 even. I would encourage you to try some of the odds and check your answers to the odds in the back of the book to make sure you're doing the right thing, and I'm confident you will be doing the right thing. Please, when you submit your assignments, as usual, put in the subject line Precalc or Precalculus, and then the page number, page 384. That helps me keep my brain straight. If you don't do that, then it slows me down considerably when I'm sorting out my 85 emails. This is due Thursday by noon. So by the time you are able to see this, which would be probably about 4:30 or so, you'll have about 20 hours to get this done. I think 20 hours should be sufficient. All right, that's it. Thank you, and see you next time. Okay, I can't stop it. Have I stopped it yet? I think I stopped it. This better be stopped. Oh my, what just happened? Oh, I didn't stop it. Now it's stopped. What in the world is it doing?